Hello, today we're going to be talking about the horizontal and vertical asymptotes of the function f of x equals x minus 1 over x squared minus 1. Now for the horizontal asymptotes, we want to know what happens when x gets sufficiently large. That is, we want to send x to positive and negative infinity. We do this using the limit. So the limit as x goes to infinity of x minus 1 over x squared minus 1. In order to evaluate this limit, the trick is to multiply the top and bottom by the highest degree variable in the denominator. In this case, we are going to multiply by 1 over x squared to the top and bottom. Now the result of this is the limit as x goes to infinity of 1 over x minus 1 over x squared divided by 1 minus 1 over x squared. Now what we want to know, or want to recall if anything, is that the limit as x goes to infinity of 1 over x to the n equals 0 for n greater than 0. So with this in mind, we know that this is 0, this is 0, and this is 0, leaving me with 0 over 1, or 0. So this means that y equals 0 is a horizontal asymptote. And in fact, this result will also occur when we send x to negative infinity. Now the next one that we want to look at is the vertical asymptotes, and that's when the possibilities of that is when the denominator is equal to 0. So that's going to occur when x is either plus or minus 1. The first one we'll look at is what happens when x equals 1. So we will let x go to 1, and we'll go from the right. And what we'll see is that this would be x minus 1 over x squared minus 1. And if we were to plug in 1 into this limit, we would get a 0 over 0. But if we do some reduction, this is the limit as x goes to 1 and to the right for this case. And that's going to be x minus 1 over x plus 1 times x minus 1. Now, we can then continue. We see that these cancel, and we are left with the limit as x goes to 1 from the right of 1 over x plus 1. Now, when we plug in 1 into this limit, we get 1 over 2. So what this says is we have x is not equals 1 is not a vertical asymptote. It is not a vertical asymptote. Now the next thing that we want to consider is what happens when x equals negative 1. So we'll do the limit as x goes to negative 1, and we'll say from the right, and that's going to be x minus 1 over x squared minus 1, which is the same as, from what we previously saw, the limit as x goes to negative 1 positive of 1 over x plus 1. Now we are choosing we are choosing x values to the right of negative 1, which means that this sum here will be positive because it will be 1 plus a smaller negative number. It would be between negative 1 and 0. So this sum will be positive. So this will in fact be approaching 1 over a positive small number. And so when we divide by a small number, we in fact get a large number. The smaller the number, the larger the number. So this would be approaching some positive big number. Again, we are choosing x's approaching negative 1 from the right. So this number is just going to get bigger and bigger the closer I choose my numbers to the right of negative 1. And in fact, the closer we get, we will then approach positive infinity. So then by definition, we get x equals negative 1 is a vertical asymptote. So for this function here, we have y equals 0 is a horizontal asymptote, and we have x equals -1 is a vertical asymptote.